controller. Therefore, there will be no problem. This problem, you will not see it if you don't make the following, mistake. If you put another weight or loop or whatever inside of this while one, then you will not observe this kind of problems. But if you are going to put another loop or whatever inside of this one, then it's going to be very dangerous. That's why what I said to you, especially when you are learning, there is only one loop in your program. Yeah, only one loop in your program. And this loop is, okay, the while one. There was, for example, a solution of this problem the student has made. When you press on this one, the button, it was starting another loop. Yeah, here, starting another loop. And it was checking the button once again, whether you have released it. So it means if I don't release this button 1 hour, your program will be there and not continue. Okay, therefore you will never see Stella, because your program is going to be there. Okay, so I pressed on this button and I don't let it go. So what? Then you have a problem. Okay, therefore this is not a good solution. In a while, there's only, as I talked to you, if you're going to use loops inside of loops, then you should be very, very, very careful. Okay? That's why I said to you, try to prevent to have more loops inside of this loop, especially if you are learning. Yes, sir?
But what about a short delay for the bouncing? It's okay to use?
It's not okay, because you don't know how much time your debouncing is going to take. It could work in a different environment. Maybe it is going to work in your environment, but if you change the environment, it will not work.
So
it's just a mechanical one.
So should we treat the bouncing now or not?
You have done it in your digital, if I'm not mistaken. There is a system set, reset flip-flop. So in fact, what you're going to do in software, you're going to do this. Look, for example, it is not this, okay, what we should discuss, but let me give you a very brief explanation of it. I have here a set reset flip-flop. Okay, set reset flip-flop. So I'm going to put here this button. Okay, this button. When I press on this one, your flip-flop will be set. So it means that you're going to have there a 1. So when it goes to 0, 0, 0 means no change, then there will nothing happen. We'll come back, it is still 1. So it means that you're going to just solve this problem, because your flip-flop will give you always 1. Okay? And in this way you can do it. And in reality what we do, okay, we call it actually synchronization. Synchronization means, okay, because you can never say to your customer, press this button exactly at this moment. That's not possible. And it can change all the time. So what we are doing, in fact, we pass the signal through a number of flip-flops so that we are going to synchronize it. So these are digital forms of solving this problem. But what you have seen in your program, you're going to have this 0, 1, 0, 1, and then it's going to be 1. Okay? So you see that you have sometimes, that's also what I've shown to you, because it is just connecting to this one, coming back once again, you're going to have 0, 1, 0, 1. In place of this one, you can have this part. Because in this part, it will only do it once, 0. Okay? And then you are going to do task only once. You're executing the task only once. So you check whether your previous value is 1 and the current value is 0. And if this is the case, you say you execute the task. That's what you do. Okay? Because if you work with delays, then you have problems, always. When you change your environment, you know that your delays are not going to work, because your let's say the statements are going to execute in a certain way. The execution time of your statements are going to determine your delay, in fact, if you are not going to use a timer, for example. Okay? So that's why. You had a question, sir?
No, I would ask if you can use a watchdog to see if he stays much time pressed, you can continue the program without waiting.
The watchdog. How are you going to set it now? What is actually a watchdog doing?
Using timers.
You can use a timer to have a certain delay. But how are you going to make it now? Suppose that I press on this button, it is a mechanical one. You remember that's why it's going to have this problem. And sometimes it's going to give me 1 microsecond, sometimes 1.2 microseconds. What happens then?
You can set a range of values.
Okay, you can continue in this way. So this is what we call ad hoc solution of the problem. It's not the solution of the problem. Suppose that you have written this program, you put it on the internet. I've got it and I'm going to test it. Suddenly it's not working. Why? Because my microcontroller could be a different one. Okay, maybe faster, maybe slower. Maybe the execution time of every statement is going to take a little bit more. Okay? Yeah? It's very, very important because look, you have different, even if you have a different compiler, it is possible that you are going to get a different delay. Yeah? So it is not so that all of the compilers are going to, look, what you do, for example, C is A plus B. Okay, this should be translated into machine language. How your compiler is going to translate it depending on the developer. So one people can do it like in your real life. You see that some of the systems are working faster than a similar system. They are doing the same function, but one is faster than the other one. So this means that the intelligence of your designer is going to be put inside of it. So therefore, it depends on many things. I suppose that you are not going to do this. Why you are not going to do this? Why you are not going to solve it in this way? And going to make the timers and this kind of things or a waiting loop, etc. In place of it, you are going to use a different technique. And this technique, I will just give you it now. We will come back to this one later on. We call it interrupt. So I start here. After 2 minutes, Stella is beyond of this door. Stella is not going to wait. There is an event. So it means that Stella has come. Okay? And she was waiting beyond of the door. She is not going to wait till I come there. In place of it, Stella is just knocking on the door. You understand? Knocking on the door. So whether I am here or there or here doesn't matter. I will hear Stella. We call this an interrupt, like what you were doing a little bit ago. I was trying to start with my lecture and I was interrupting, okay? You was interrupting me all the time. You're coming in. You're coming in. Coming in. You see? I see you, of course. If I don't see you, then I'm not going to react on this one. So what Stella is going to do, knocks on the door, and if Stella